Alright, welcome to class. Hopefully you've already turned in your assignment from the previous class, and we should be ready to take a look at this 8.3 Special Triangles Exploration. In trigonometry, since that's kind of what we're studying in this chapter, we are going to notice some special triangles that are created that have unique relationships, and we're going to use Pythagorean theorem on this page. Now make sure you are on the 8.3 Special Triangles Exploration page. If your page does not look like this, then you're on the wrong page. So please make sure you are on this page in your notes. I'm going to show you some demonstrations on how to get started on this, and then I'm going to have you do a lot of work on your own, and then so there'll be times where the video needs to be paused so that the students can get caught up. Let's make sure that we're all on that same page together and getting this done. Okay, so now one of our special triangles, and it's going to have a special name which we'll look at here in a minute, comes from starting with a square. I know, you're looking at this. This is not a triangle, but here's how we're going to create this special triangle. So follow along with me, please. I want you to, and I do want you to use a straight edge. Okay, so make sure you have that. If you need to pause the video to allow everyone to get a straight edge out, go ahead and do that. But I want you to draw a diagonal with your straight edge. Just draw one diagonal, not both, just one, to separate this square into two triangles, and we're only going to look at one of those. Okay, so I'm going to cover up one of those because I don't need that one. We're just looking at this triangle. Now, I covered up my directions. Sorry. I want you to determine the angle measures of, it says the two triangles form, but really just this one. I want you to find the angle measures, and you're going to do that using this, and I'm going to help you with this so that not everyone has to, excuse me, backwards. Not everyone has to, nope, now it's right. There we go. Not everyone has to have one of these. We're just going to figure it out ourselves, all right? So we're going to work through this together. Now, it's a square. You guys can measure if you want, but you know that this is a right angle. See, one angle is 90 degrees. Let's call this angle 1. Okay, angle 1 is 90 degrees. Okay, we're going to call this top angle 2, this angle 3. So we're going to measure angle 2. Again, we're not worried about the other one. We're just going to measure that angle. Okay, so if I line up this edge here, and then I'm going to look where this goes through, that's halfway between 40 and 50 degrees. That means it's at 45 degrees. So angle 2 is 45 degrees. Okay, if I measure this angle down here at 3, it's also halfway between 40 and 50 degrees, and you get 45 degrees for angle 3 also. Okay, since the two acute angles are both 45 degrees, and it's a right triangle with a 90-degree angle, this is a special right triangle that we will call 45, 45, 90. Okay, we will call this from now on a 45, 45, 90 special right triangle. So here's what I would like you to do. This is where you're going to get some time to pause the video and to do this after I give you these instructions. I want you to draw one diagonal for each of these again, creating these 45, 45, 90 triangles. Draw the same diagonal for all four examples, and then I want you to use Pythagorean theorem to solve for the length of that diagonal. We're going to call the length of that diagonal c. So you're going to do a squared plus b squared equals c squared for all four of these examples. And you're going to find out what c equals for each one. Okay? So remember, the two legs here, we're only looking at one of the triangles. The two legs of a 45, 45, 90 triangle are going to be the same because they're sides of a square. Okay? So I want you to do that, and I want you to write your answers in simplest radical form. Alright, so at this point, pause the video and go ahead and spend some time working on problems 1, 2, 3, and 4, and then when everyone is done, you can continue watching the rest of this video. Okay, hopefully you've had time to complete these, and these are the lengths we should get for the diagonal of each of these squares. In example 1, when you have a square with side lengths of 3, the two legs of this right triangle are both 3's, and when you use Pythagorean theorem and write your answer in simplest radical form, the length of the diagonal is 3 root 2. For number 2, when you do Pythagorean theorem for these two sides to find c, you get square root of 50, which is 5 root 2. Notice that each of the sides of that triangle are 5. Each of the legs here are 4, we get 4 root 2. Each of the legs here are 7, we get 7 root 2. So here's what I would like for you to do. Take some time to talk with a partner, and this is another point where you'll pause the video. I want you to answer this question. Is there a pattern you discovered about how to find the diagonal length in each of these squares? Or, instead of diagonal length, you can think of that as the hypotenuse of a 45, 45, 90 triangle. Okay? So if you're given answer that question, yes or no, then given a side of any one of these squares, describe how to find the diagonal. Or if you're given a leg of any 45, 45, 90 triangle, tell how to find the leg without using the Pythagorean theorem. Okay? And then when you're ready to kind of check the answers you've come up with, you can push play on the video. Alright, this is the pattern we should have come up with. Alright, the side of the square times radical 2 is the pattern we end up with. Every time you look at one of these squares, the diagonal will always be whatever side length that is times root 2. Alright, let's go to the back. We're going to move through this part a little more quickly. I'm going to help you set this up. Okay, I want you to draw a perpendicular bisector of this triangle. Okay, what that means is we're just going to draw a line that is perpendicular to this base of the triangle through this. This is an equilateral triangle. So if I wanted to find the bisector, I can measure this out. That's 4.5 centimeters. Half of 4.5 is 2.25. Okay, I line that up. Okay. And then I want you to find the angle measures of one of these triangles. Again, let's just focus on one. Okay. Now, when this side the side of each of these is 4.5, and this is 2.5. All right. So when we create a right triangle here, I want you to measure these two angles. All right. We're going to call this angle 3 this time. Put these in order. So this third angle here is the right angle, 90 degrees. And when I measure these other two, this angle is 60 degrees. Call that angle 2. And angle 1 at the top is 30 degrees. So we get a special right triangle when we take half of an equilateral triangle called a 30, 60, 90 special triangle. Okay, so what I want you to do on each of these is measure. You don't have to measure the angles again. I'm sorry, I didn't mean to say measure. Now, remember, we're creating a perpendicular bisector, so we're cutting this length in half. Okay? So this side here is not 4, it is 2. So I want you to use Pythagorean theorem again, a squared plus b squared equals c squared, to find this segment that you're drawing in. Now, the side of the original triangle becomes the hypotenuse of the right triangle. So this is C, this is A. We're looking for B in each of these. So when we plug in our numbers, you will put in a number for A, which is going to be half of that side. But then we are going to stop here and not write a number for B because that's what we're looking for, and the hypotenuse is this other side. Okay, so we're going to have to subtract whatever 2 squared is from both sides and get to the end. Again, write your answer in simplest radical form. Okay, pause the video to give yourself enough time to do that. All right, these are the answers we should get. All right, these are the results we should get. This line drawn in for B is 2 root 3. This line is 5 root 3. This one is 3 root 3, and this one is 4 root 3. So once again, I want you to talk about the pattern with a partner, and then when you are completed with that, when you're done, go ahead and continue watching the video to see what the pattern is. All right, pause the video here. Okay, what we should notice is to find the altitude of this triangle, we're going to take half of that side length and multiply it by the square root of 3 every time.